Okay, time is there. Hi, I'm very excited to see so many people coming to our talk. We know it's late in the day. Have probably learned too many things already today, but we will have a very good talk about the data-driven approach to application security. Before we go ahead, we'll just say a few words about ourselves. My name is Kristian. I have a master's degree in space physics, but I have worked with software development and application security for the last 5 years in Equinor. And ever since I worked with physics, I love to automate things. And you will also see that today, how we are working on automation. So together with me, I also have Petter.
Hello. Yes, so my name is Petter. I have been a software developer for a long time. About 10 years, I've been doing desktop software development, cloud, front-end, back-end, DevOps. Yeah, most of the things. So the last year, since last February, I have been a member of the Equinor application security team. So I spent the last year focusing on that. And I see that my career is pretty much modeling many softwares. It's starting off with some kind of desktop application, gradually moving into the cloud, and then finally we slap some security on the end. So if you have the opportunity, don't do it that way, do it the other way around, so you don't figure out you've been spending 10 years writing insecure crap.
Yes, so before we go ahead with our talk, we'll just say a few words about what we are doing in Equinor. So we are part of a new team called AppSec team. It was established 1st of February last year, so we soon have our 1-year birthday. We are currently 6 people in both Bergen and Stavanger. But we see there is a lot of work to do in this area, so we are looking to grow. If you want to know more about this, we also have a site, appsec.equinor.com, where all the information we have is open source, so we really like to share with the rest of the community. So some of the activities we do in the AppSec team is we hold threat modeling sessions. We preach about shift-left security, like Petter have recently learned, and we hold a lot of training as well. We do container security training, security scanning training, and recently we have also started a security champion program, which we will mention a little bit more later. But for now, we'll focus on the scanning part. Of course, we are using Snyk, but there are a ton of tools out there. So to conclude, the goal of our department is to reduce the cybersecurity risk in Equinor software development lifecycle. So what is the problem here? Most software today consists of external dependencies. By some accounts, more than 80% of the code that's running in your application is actually not written by you or your team at all. It's all the open source dependencies that you use. And this, of course, introduces potential vulnerabilities. And for everyone that have written a JavaScript project, and if you let it be for 3 months, open it again, do npm install, you'll have most likely hundreds, if not thousands, of outdated dependencies. Things are evolving very quickly here. And even worse than that, you have potentially not only outdated dependencies, but you have malicious code. Let's check here. How many people here are actually doing a code review of the external dependencies you are using? Raise your hand. I see a half hand. And in many cases, that's true for other people. Most people do not vet the external code, and that's what we also saw for log4shell, that code had been there for almost 10 years, and nobody bothered reading through it. Here we can see a graph of like the usage of packages in JavaScript for the last 10 years. You see that the usage of external dependencies is growing exponentially. This was only until 2020, but it has been growing in the same pace since that. And we can expect that this trend will follow in the future as well. So having overview of what source code dependencies you are having is getting more and more important. So what we did in our department, we started out with, we were maybe a little bit naive, but we thought, okay, let's just scan everything. Let's scan our dependency files, let's scan our manifests. Some teams have a software bill of materials. Let's scan Docker files. Can even scan running images in Kubernetes. Let's scan our infrastructure as code files. There are so many things you can scan. Scan your licenses. So we thought, okay, let's just scan everything, and we will be very secure. So that was our mindset when we started. So we did some research. We looked into SonarQube, Coverity, Dependabot, and they all have some like advantages, disadvantages. In the end, we went with Snyk, but I think when it comes to the software composition analysis, most of these tools like do similar work. So we thought, okay, let's just put on the scanning, problem solved, let's go home, right? But it wasn't that easy, was it, Petter?
No, it wasn't. So yeah, as Kristian is alluding to, clearly scanning your things and getting all the information about what's potentially problematic in your code is not enough. It simply doesn't equal, or it doesn't imply that the teams are immediately going to start fixing them. So we have talked with the teams, and we're trying to kind of understand why we're seeing this pattern. People are onboarding, there's 100 vulnerabilities, and it's just staying there. So we're trying to kind of figure that out. And we think a lot of it is down to false positives. So for example, when we had this Spring4Shell issue, then all the dashboards were beaming like this is a critical alert. And then you go into the defect and you see that, well, you actually have to run a certain web server, you have to have a certain version of Java, etc., for this vulnerability to actually apply to you. So then people are seeing that, well, this is, I don't like to get these critical alerts when there's actually nothing that's a problem. So that is clearly one component. The second one is kind of related, that is cognitive overload. So what typically happens is, as Kristian was saying, you have a JavaScript project, you have bootstrapped that for, like, let's say half a year ago, and you haven't really worried about your dependencies. And at this point now you start scanning, and suddenly you have like 100 vulnerabilities right there. And dealing with 100 vulnerabilities in an environment where you have delivery dates, you have kind of all this kind of pressure outside of this problem. And in addition, there's a lot of false positives, and it's really easy to kind of respond to that cognitive overload with passivity or paralysis. It's too much to be able to deal with it. The third point is that a team often consists of a few software developers and a product owner. We have many small teams. And software developers are really good at building things, and that's often their passion, this is what they love. And the product owner, the perspective is often that, well, I have professional software developers, so then security is kind of implicit. You imply that you are buying a service, and security is built into that. But when you don't have a kind of dedicated security conscience in the team, if you will, like a security champion, then kind of you need to have one person that is driving it for it to actually happen. In this talk, we will mainly be talking about how we are trying to deal with the cognitive overload. So we think that an essential part of that is to be able to ask some specific questions against your vulnerability database. That's on the next slide. Christian has been playing with DALL-E. So all the graphics here are AI generated. The next slides are created with ChatGPT. No, that's actually a joke. We wrote them ourselves, but the graphics is AI. Yes?
Follow-up question. How many teams are you in?
Many. It's like...
We'll get a little bit back to that
Yeah, I think
later in the talk.
Hundreds or thousands or?
I think it's definitely hundreds.
It's more than 200 teams, definitely.
Yes. So if we want to ask specific questions against our data of vulnerabilities, the first question we want to be able to ask is, of course, which are the most important vulnerabilities to fix. Somehow we want to kind of understand what is the most important thing here, and that's to reduce the cognitive load. Another thing to scope down could be, if I'm a front-end developer, for example, I really only want to see things related to NPM. And when we're using tools like Snyk, we have a team, and there is the front end, there's the back end, there's the infrastructure, there's the Docker. Everything is there, so kind of how can we remove this to reduce this to just see the front end specific things. There's also kind of the inventory. What kind of vulnerabilities do we have? If we can ask that question, we can also ask questions like, do I have log4j somewhere, or something like that. And of course, how does this evolve over time? Are we getting better? Are we getting worse? It's always nice to, it's the same that we do with compiler warnings. You start off with a ton, and then you kind of are able to burn it down. That's kind of motivating. So also just knowing and also getting that reward by seeing something being burned down. That's nice. So yeah, you want to talk a little bit about the stakeholders?
So the thing is, like, first of all, like, having all this insight is great for the teams, that they can get to know what they should spend their time on. But we also figured out, when we have all this immense amount of information from all the dependencies, that could be interesting, for instance, for product owners, like people responsible for a group of applications, and they want to have an overview of what vulnerabilities should they focus on with their team, to kind of get an aggregated view. And that's something we have struggled before, and that we kind of wanted to find an answer to. And then from a whole corporate perspective, come into the questions we got asked earlier, like, we have more than 6,000 repositories in GitHub, and we have about almost the same in GitLab as well. We have more than 250 teams writing about the same number of applications. How much of that code base is scanned? How much is actually secure? We have more than 2,000 developers writing code on a daily basis for us. It's like, where are the vulnerabilities? And then also, like, when we are doing training with the developer community, where should we focus? Like, Is it container vulnerabilities? Most of our applications are deployed in Kubernetes, but are teams using secure base images, or are they running full VMs in Docker? That's also something we want to see. Like where should we? Because like I said, we are only 6 people in our team. Like how can we spend our energy best to improve our security? And then lately, we also want to know the training and the courses we are holding, like what effect does it have? Is it actually improving the security posture? So we want to be able to kind of measure the performance as well. I don't like to use the word KPI, but we would like to have some insight into, for instance, mean time to fix, like from a new vulnerability is into the wild, like how long do the teams use on average to kind of mitigate the vulnerability? And that's something we would want to like track over time as well to see how we are improving. And also, like we talked about earlier, like when you have a new critical vulnerability, like Log4Shell, like which teams are affected and how can we reach out to them as fast as possible. So these questions you see here, that's kind of questions we asked ourselves after we started gathering all this insight. And then we kind of had to come up with a solution to it. And after thinking hard and long, we figured out we need a platform.
Yes. So obviously, this problem calls for a data platform. Who doesn't love a data platform? So we kind of coined this as a data platform for filtering, slicing, and dicing the vulnerability data and reduce it to something actionable. So we went ahead and tried this, trying to do as a low-cost version of that as possible. And the question is, of course, how can we build such a data platform? Well, we know that our primary vendor for vulnerability data is Snyk, and they have an API which lets us download all the projects that we have in Equinor, all the organizations, all the vulnerability data that's there. So the API is there. Also, GitHub has a very comprehensive API. We can download all the metadata, all the repositories that we would need to kind of underpin this data platform. We store that in a database. And once this is in a database that we control, then we can put a dashboard on top of that, do some analytics, make some charts, make some tables, and yeah, make dashboards which are tuned to this use case. And there you would be able to, of course, filter and scope all the data down to what actually matters for you. Finally, we would be able to share this dashboard with development teams and the stakeholders, as Kristian mentioned. The architecture that we have landed on is, it looks like this. So on the left-hand side, we have our data sources. There's a GitHub action. It is running nightly, basically shuffling all the data from the sources into the Postgres database. There's a key vault as well for all the credentials. And on the right-hand side, we have deployed something called Apache Superset. And that is an open source business intelligence app. It would be quite similar to Tableau or Looker or Power BI. We have deployed that in our internal container platform called Radix. Even if it's late on the last day, I will talk a little bit about the nitty-gritty, but I will try to not spend too long on that. So the whole concept is related to extracting, loading, and transforming In the extraction phase, as we said, we had the scheduled GitHub action running every night. There's a Python script that invokes all the APIs and gets all the information there. In the loading phase, that's basically moving this into the Postgres database. We are using a couple of libraries to make that easy. So there's SQL Alchemy that is kind of easily putting JSON data into the database without having to do SQL, which is always good news. We have Alembic for auto-generating the migrations, so it's kind of easy to work with this. It's also nice for the local development because you can spin up the database, you can spin up the dashboard, everything is like self-contained, so it's easy to test things locally. In terms of the schema itself, this is quite tricky because vulnerability data is typically quite a big schema, so we don't want to kind of maintain that on our side. So we have tried to do, we are using this JSON B field in Postgres, which makes it easy to store unstructured data. But also in the transform phase, you can actually kind of take a JSON and transform that into a table row, like in the runtime. So that's kind of a decision to, once our vendors are changing the schema, then we are still ingesting the data, but we might have to do something on the visualization layer instead of the ingestion being broken. Yeah, and once you have this, all this JSON stuff in tables, then we can use the BI solution that is like no code or low code dashboard builder, and at that point, you don't really have to worry about the nitty-gritty anymore. And also you don't have to, because I'm done with this slide. Okay, just heading into a demonstration of the solution. So this is what the landing page of Superset looks like. It's pretty much what you expect. You have all your dashboards links to there, and there's a few modules, charts for editing charts. There's also a SQL lab, which I have found really useful in development because then you can just open it and write some SQL and explore your data. And then finally, it's editing your data sources in the data tab. We'll head right into the use cases. So the first use case that we have talked about is the inventory use case. So what we see here is a table with all the issues that we have in Equinor. And it's easy to filter this table. So if you're looking for something specific, like maybe you want to see all the remote code execution bugs that we have, then we can filter on those. And then, yeah, the table is scoped down to that. So in a similar way, we can, if we're looking for a log4shell issues, then in the same way we can search on the package name, and then we can immediately see what we have of that. Then you can also, of course, sort by the priority scores, which you would typically do. So that was the inventory use case. The next use case is how are things evolving over time, and that is as you would expect. It's just a time series graph. It's stacked, has a split on the critical, on the high, on the medium, and the low severity cases. So it looks like we are doing really, really great here, but the fact is that we have split our vulnerability data from a big team out in a separate organization. Looks great if you're showing it to the managers. Don't tell anyone. Next one is just simply how it can help prioritize issues. We have the table of the issues in the main dashboard, and simply just the most important things are floating to the top. The problem areas is where it kind of gets a little bit interesting, and where we can kind of leverage the underpinning data in ways that is much harder to do in something like the Sneak portal. So we can see here what kind of projects are we scanning. In Equinor, we have a lot of .NET, so NuGet has by far the biggest slice of types of projects that we are scanning. And so the next one is Terraform. We got some Docker files, Kubernetes config, SAST. And the smaller slices are typically now the NPMs and the pips and the poetries and the kind of application dependencies. The next chart, we're trying to see, well, what kind of issues are actually contributing with the biggest number of the first chart. Like we have all this big number of vulnerabilities, and what's kind of the main components of that. So what we see here is that the Docker file is by far the biggest contributor for vulnerabilities in our system. The next one is SAST. That has been coming up fast lately. And that's basically because people are starting to use it, so that's really good. The next one is Debian. And the conclusion for this is actually that, so if we were able to address the Docker file issues, then it's like we just have 1/3 of the issues left or something like that, or maybe even better. And we also see that, for example, NuGet, which is, half of the projects are NuGet, but they're actually not represented here at all. So I don't need to be chasing down the .NET guys at all. They are doing great. But those Docker chaps, we need to have a chat. Yeah, and so we also expanded a little bit on that to understand what kind of base images we have. So then we can make a table. We can see that a lot of people are using the fat base images, as Kristian was also saying. So we're trying to figure out what kinds of base images do the projects which have the most vulnerabilities use. So then we see that, the Python is the big problem. Now, as a response to this information, we have launched a workshop internally where we're trying to provide training, help people use Slim base images, just cut down on all the unnecessary stuff. And we know that sometimes it's a 10-minute job, right? Just change it to Slim, or like one day if you change to Alpine. So it's kind of simple, but people have to know about this. So we try to provide the training, provide the workshops. But that is kind of, it's nice that we have something that we can do and to chase, but we also want to be able to understand if that had any effect at all. So then it comes to the kind of the retrospective approach. So what I'm doing here is I have the same dashboard, and I am trying to filter that on Debian, Dockerfile, and Alpine Package Manager. That's the main Docker drivers. So I filter on that now, and the whole dashboard is scoped down to that. And then I can see, with only looking at Docker images, correlate with whatever initiatives I was doing, and see, did that have an effect? Or was it helping a lot? Was it helping a little? And then we can adjust our approach based on that. Trying to learn if we're doing well. I have a couple of just filter use cases as well. It's pretty similar to the Docker one. So the front-end developer would probably just be interested in NPM. So I can go to this pie chart and just click on NPM, and now this front-end developer can see how is my project doing over time, what are my top priorities at this point, and yeah, all the other associated metrics in the dashboard as well. Exactly the same thing for organization. So it doesn't look so good when it's blurred, but underneath the blur, we are selecting some organizations and scoping that down. And now they can see that it's not going so well. Yeah. The final kind of story from the dashboard demo is when we have some really, really specific question, then it's nice to have be able to drop down into SQL. We're now in the SQL lab. And the example here is, oh, I forgot. I was in other talks in the conference, and people have apologized for showing YAML, for showing assembly, for showing one thing or the other, and it's now my turn to apologize for the SQL. But yet here it is. So what's going on here? We are selecting some things. We don't look at that just yet. From. And it is from clause we have, it's basically the kind of the JSON and explode that into a table. So it's basically just that transformation. The issue ID is like something log4j. I'm trying to find all the issues that are related to log4j. And I'm grouping by that issue so that now I can have one row for every log4j issue in our system. And finally, coming back to the select statement, just the ID. I'm counting how many organizations have this issue. And I'm calling this Postgres function called string_ag, which is basically concatenating all the users in Snyk that are being affected by this issue. So when we run that, this is what you get. So we get all the issues, how many organizations have it, and I can go into here and I can just copy-paste the list of all the affected users, and now I have an easy way to reach every person in Equinor who has this this issue in their Snyk organization. And I think that concludes the demo. Kristian will tell you more about more challenges.
Still AI generated here, challenges. Of course, it's not all just plain sailing. We still have the issue with dependencies flagged as vulnerable when they are not reachable. You probably noticed, like, even though you are importing a dependency, it doesn't mean that particular dependency is reachable in your production code. And we see that in many cases that it's, for instance, only used in like unit tests locally, but they are never exposed in the production environment. But those vulnerabilities would still show up in our platform solution here. We have the same with the double counting. You remember this big drop in number of vulnerabilities? That's because we took our Kubernetes integration out in a different group, and then you could see the number of like vulnerabilities going down to half. But it's the same number of vulnerabilities, it's just that they are not double counted anymore. We also have the issue with, we have code from almost like these 6,000 repositories, but we don't have so much metadata regarding the repos that of course, we have the Git contributors, but we don't know which kind of department in the company they are belonging to, which is the product owner, and a lot of metadata around these projects. And that's actually something we have kicked off after we started doing this analyzing, is saying that, hey, we need some more oversight into our source code so that we actually know exactly what we have in our inventory. And then the last point is that how do we motivate the teams? Like we have, like I said, more than 2,000 developers. Of course, we have a lot of people very interested and eager to learn more, but I don't think we can expect everyone to be as motivated as you guys sitting in this room here. So how can we reach out to the rest? One thing we have done is that we have kicked off a security champion network. We actually, I think we have quite a few of our network in the room today. You raise your hand. Hey! Yes, so the point about Security Champion Network is that you don't have to be an expert to be a part of it. This is formed by the community, and it's for people that are interested and willing to learn new things. So we hold like weekly coffee seminars and monthly learning sessions as well. So this is a great way for us to quickly reach out to a large part of the community. I think since we kicked off in October, we have about 100 teams, development teams onboarded, and we have 1 to 2 developer per team. So I think last time I checked, we have 160 developers in the community. But if we say every team is on average maybe 5-6 people, it means in this network we can easily reach out to more than 700 developers. So when there are new vulnerabilities and things we want to inform about, this is a very effective way of reaching out to the community. Again, all our information about the network is open. We learned from, actually the whole network was kicked off after a ID from NAV that has the same. So, and they also took initiative to creating the Security Champion Norway network. So for those of you that don't have a network yet, you should check out Security Champion Norway, and there is also a community with other companies in Norway.
Yeah, just a few words about the way forward. So the first thing that we want to consider is to add data sources, and definitely the first thing is cloud provider data. So at least in our setting, which is usually in Azure, we have Microsoft Defender running in our subscriptions, and they also have quite a lot of security warnings. So it'd be really nice if we could take those warnings as well and put that into a kind of like a one-stop shop where you can get all your security signals or metrics from. Another thing that we are currently experimenting with is to ingest Snyk events. So if you use Snyk, you can use this webhook feature, which is going to send you something about every event that's happening. So every time we're scanning, we get sent an event. And this event is containing what project was it regarding, what organization was it regarding, and were there any introduced issues here, or were there any removed issues here? So we set that up and put that also in a database. And that lets us get a more like a real-time view of the situation. For example, here we see the last 7 days, how many issues are coming in, and it's now grouped by the organization. So now we can identify if some organization is having a large influx of issues. And of course, similarly, we are able to identify if there are organizations that are doing particularly great at this, then we can reach out to them, ask What's the secret sauce? What's making you do so well? So that's also interesting insights to gain. And when we demonstrated that internally, it was also observed that sometimes you have the same team has a lot of incoming, also a lot of outgoing. So in order to capture that as well, we plot this in a scatter plot. It's a bit hard to read. On the x-axis, we have the number of removed issues. On the y-axis, it's the number of introduced issues. So all the dots here, they represent one organization. And to sum that up as simple as I can, it's a good here and bad here. So it's easier visually to identify really strong performers in this chart.
So if you fix more than new introduced, you will be below the line here. So then we can see how they are managing to fix more than new coming. So.
Yeah. So I think that was the last slide. So thanks a lot for listening. It was good fun to be here at NDC and really enjoyed that. I left our contact information if you want to talk about this. Just drop any of us a line. You can also find me on LinkedIn. Yeah. Any questions? Yes. Oh, okay.
Have you looked into if any of the teams are able to avoid vulnerabilities? Because here you're talking a lot about removing the incidents. That means they are already vulnerable, right?
Yeah. So, do you mean if anyone are actually reaching zero, or?
No, if they are able to not introduce vulnerabilities when they are developing code,
Right.
instead of having to fix them reactively.
I would say that we are probably in a phase where this is being introduced, and the main issue is that when you introduce it, there's already a lot. So kind of, I don't think we have many like greenfield projects that are starting off the bat with scanning.
And you have to remember, even when you have zero vulnerabilities, over time there will always be more and more vulnerabilities kind of coming in afterwards. But what we are working on is we are encouraging the teams to use sneak scanner in their IDE, so you can have it directly in, for an example, Visual Studio Code, that you will get vulnerability warnings like scanned on your source code while you are writing. And we also, all teams are suggested to set up a CI/CD pipeline, so actually you will scan your pull requests and get rid of them before they are merged into the main branch. Yeah. Yeah, Evan.
Yeah. So, do you have any, like, when you do the like a workshop or whatever with like Docker? Do you see any trends with the packages? Like, do they go down or do they stay the same? Are the workshops effective?
Yeah, that's what we're trying to understand. So we haven't been running them for that long. I have seen examples that like the day after, suddenly one team's like, boom, 300 vulnerabilities taken away. But I wouldn't say that we have seen that on a scale. And we've also challenged to kind of, if we are doing a workshop and it's a voluntarily sign up, so like we want to help, but then kind of people also want to have to join the workshop, and kind of scaling that, like when we are doing 12 developers at a time and there's 2,000 developers, it's challenging. So we haven't really been able to see that effect on a scale yet.
And you have to remember, those people attending the workshop first are usually the most interested people. So they also have a tendency to have everything in good shape before. So the challenge is to reach out to those people that do not want to attend the workshop.
Yeah.
I think we had a question over here.
I've been in a similar situation, and one of the challenges we had was that when we reached out to the technical people in the team, they said, "Oh yeah, we know, we should fix it." But then reality hit, and their product owners did not prioritize this kind of work. So, are you experiencing a similar situation that it's hard to get traction from management, or have you found any ways around that?
Yeah, it's definitely something that we see as well, but there's also a shift, like with the whole security thing becoming a really big thing, like the last year or so. It seems like it's becoming easier, but I've definitely also seen that, and it's not always it's not always that they aren't willing to. It's like if no one actually says now we have to do this, it doesn't happen. So it's both that maybe there isn't that person that wants like personality to do this, but also there has been challenges in terms of kind of having the product owner allocating time as well. But there I have no good answers like how do you deal with that. But fortunately, in a way, this is becoming more like prioritized on a wider scale in the organization and recognized as important.
I have a comment as well. That I think we are working on multiple angles of this. Like you see the security champion network, that's a very bottom-up approach, like a grassroots movement. But then on the same time, we are also working on kind of teaching the product owners about security, because many of them, they don't really have a deep technical background, and we need to educate them on the work we are doing as well. So we have kind of made a tour in management groups as well to tell them about the importance of application security. Because I think in many cases, it's not that they don't care or don't want to fix it, it's just that they don't know and don't know how they can contribute. So that is equally important as working with the developers. Okay, back here.
The management, okay, for the views, yeah. Now the management has access to those dashboards, right?
We are working on it, yes, but the problem has been grouping them together, because one manager might have 3-4 applications, and how can we automate the access for the manager? So that's why we're working on the metadata from the repository, so we can do that automatically. Yes.
Yeah, because are you logging if they're actually using it as well? Because I think that's crucial for the management, because they don't know, right? They don't see it, it's too deep, it's too technical. If they get the graph, they understand the graph, and it's going the wrong way.
But also we are very cautious about if we just introduce it and they will see 1,000 high vulnerabilities, they're gonna press the alarm and start the task force tracking it down, and then all the developers are gonna be angry at us for like revealing this data, right?
See your point,
So we kind of need to be also very cautious about how we present it. No.
Good point.
Okay, question in front there.
First of all, really nice presentation. Regarding the graph about the technologies used, right? You have the one with NuGet, npm, Docker, and so forth, and the graph with the vulnerabilities there. Do you have an approach to link the number of vulnerabilities with the lines of code, or the percentage of that technology in your code base? So for example, here you have npm, which has maybe 3%, I would say, but the ratio between the code base and the vulnerability is quite high versus the others. And would you include that, for example, as in a code review to be more stringent when you merge something with that technology?
That's an interesting question. We currently aren't linking, so we are linking with GitHub, but that is just to measure the coverage. Like, we have a repo, is it covered or is it not? That's pretty much the extent of the joining that we do. So we don't actually download the code, and we don't have this that kind of metric for the code. But that's an interesting idea.
One last question, anyone? Okay, and I think we'll say thanks for us. And
Thank you.